Hello everyone, this is chapter 12, which is Introduction to Organic Chemistry. Till now we have studied the basics of chemistry. Now we are moving forward with organic compounds, which is a slightly different type of chemistry that we have learned so far for Chem 119. Now what are organic compounds? Organic compounds are the compounds which normally we can see in vegetable oil, which are not soluble in water. Now, to specify organic compounds, they basically contain carbon and hydrogen, and this is the reason they are also known as hydrocarbons. They can also contain nonmetals such as oxygen, sulfur, nitrogen, phosphorus, halogen, in addition to carbon and hydrogen. They are found commonly in gasoline, medicines, shampoos, plastics, perfumes. Depending on what functional group the organic compound has, we can classify them or we can organize them. We can also classify them best based on what type of bonds they have. Some properties of organic compounds are they have covalent bonds, they have low melting and boiling points, they are flammable, and they undergo combustion. They are not soluble in water. If you consider vegetable oil or cooking oil, that is a mixture of different organic compounds. And if you try to pour vegetable oil into water, you will see that it's not getting dissolved in water. The table represents some of the organic compounds, the example and what type of elements they have, and some properties involved with it. If you look at the first one, the organic compounds, they can contain carbon, hydrogen, oxygen, sulfur, nitrogen, phosphorus, halogens. With carbon and hydrogen, one example is C3H8, whereas in organic compounds, they are mostly metals and nonmetals. Example is regular table salt, which is sodium chloride. Now, if you consider C3H8 and sodium chloride is made of ions, sodium plus, which is sodium cation, and chloride anion. Whereas C3H8, it has only covalent bonds. It is non-polar. Its melting point is minus 188 degrees Celsius and boiling point is minus 42 degrees Celsius. It also burns in air and not soluble in water. Whereas if you compare sodium chloride, which is the regular table salt, it is an ionic compound. Its melting point is 801 degrees Celsius, which is pretty high. Boiling point is 1413 degrees Celsius. It does not burn or not flammable, and it is soluble in water. Now, this is a learning check where these are some properties and we have to recognize which one is for organic compounds and which one is for inorganic compounds. High melting point, which is normally incorporated with inorganic compounds, not soluble in water, which is organic compounds, contains hydrogen and carbon, organic compounds. The formula, which has magnesium chloride, so magnesium is a metal and chloride, it is halogen. It's inorganic compounds which burns easily in air. That is a property of organic compound. Now, hydrocarbons, as I mentioned, they have mainly carbon and hydrogen. In organic molecules, carbon has 4 bonds. Why? If you remember from Chem 119, carbon has a valency of 4, so it can accommodate 4 bonds maximum. In methane, which is CH4, the carbon atom forms an octet by sharing its 4 valence electrons with 4 hydrogen atoms. To understand this, you have to brush up the knowledge from Chem 119, which is how to draw Lewis structure based on the valence electrons. In this case, if you draw the Lewis structure, you will see that carbon has 4 bonds surrounding it, and the shape for carbon is tetrahedral, and the angle is 109 degree. If you consider again methane, we can also draw it in this kind of expanded structural formula where you draw the carbon in the middle and 4 hydrogen with the single bonds are spreaded at 4 different directions. And condensed formula is where we write down the carbon and the hydrogen and the number associated with it, and we do not spread it out. So we can draw organic compounds in 2 different ways. One is the expanded formula where you actually show how many bonds and what type of bonds we have in the compound. And one is condensed formula where we just write down the elements with the number associated with them. Now, methane has 4 covalent bonds and it is tetrahedral structure, and bond angles are 109 degrees Celsius, which is shown here with the ball stick model as well as the structure, the expanded model. It is referred as saturated hydrocarbon because all the bonds present in methane is single bonds or sigma bonds. The next compound is ethane, C2H6. In this case, we have 2 carbon and 6 hydrogen. If we want to draw the structure, we get it like this, where 2 carbons are bonded with a single bond and each carbon bearing 3 hydrogens. If we want to consider butane, which is C4H10, and if we want to predict the shape around each carbon in this case has 4 bonds attached to it, and all of them are sigma bonds. So it has a tetrahedral shape.